Distributive property. As a reminder, multiplication is just repeated addition. And then in this section, in order of operations, using distributive property is considered a multiplication step and not a parenthesis step. Now, let's go ahead and solve this first example, and we're going to use two different methods. So the first method, we're going to use addition. So what happens is we have this 30x plus 25y, and we have 3 of them. So we're just going to add them all together like this. Oops, forgot the y there. Okay, so then we add the ones that have like terms, right? So we have x, x, and x. So 30 plus this 30 is 60, plus this 30 is 90x. Now 25 plus 25 is 50, plus another 25 is 75. So we would write plus 70y. So that is how we would do it if we use the addition method of just adding up all the terms together. But what distributive property does is it allows us to take this number 3 and multiply it by the first term, which is the 30x, and then the second term, which is the 25y. So 3 times 30 is equal to 90x. And then 3 times 25 is equal to 75. So then we would have 75, and we just leave it as in terms of x and y like that. So you can see that we have the same answer in both, but one method was a little bit faster to get to, which would be using the distributive property using multiplication. So let's do another example using this method. Example 2, coolant systems in cars. To determine the amount of antifreeze and water that should be in the coolant system, we can do the following calculation below. This is for a vehicle that holds 12 liters of coolant. Each vehicle holds a different amount, ranging from 8 to 18 liters. So we have X, which is our antifreeze, and Y is considered our water. And so if the solution calls for half and half, which is also represented as 0.5 for each, then we can write an expression like this to find out how much of each do we need. So essentially we have 12 times 0.5. Now 12 times 0.5, 2 times 5 is 10, carry the 1, 5 times 1 is 5, plus 1 is 6. Then we have 1 decimal to worry about, and so we move it over, and we get 6. So when we multiply this out, 12 times 0.5, based upon this, we get 6x, and we get plus 6y, as it's the same multiplication of 0.5 times 12, except we have a y at the end. So we would say we need 6 liters of antifreeze and 6 liters of water for this problem. So let's go ahead and do another example. Example 3. Determine the amount of antifreeze and water that should be in the coolant system of a vehicle that holds 16 liters. Use the equation below to solve. So once again, we have X is our antifreeze, Y is our water, but now we have 16 out in the front. So 16 times 0.5, 5 times 6 is 30, carry the 3, 5 times 1 is 5, plus that 3 is 8. So now we have 1 decimal to worry about, so we move it over, and we get 8. So now we have to multiply the 16 by this 0.5, and then 16 times that 0.5. So therefore, 16 times 0.5x is equal to 8x. Then 16 times 0.5y is equal to 8y. And this would be our solution to this problem, as we will need 8 liters of antifreeze and 8 liters of water. So let's do one final example. Solve for the following. We have 2 out in the front, and then we have everything within. So let's multiply the 2 times 3.5 first, then the 7y, and then the 9z. So we can also write this like 2 times 3.5. If you're not sure, just go ahead and multiply real quick. 0.5, or 5 times 2 is 10, carry the 1. 2 times 3 is 6, plus that 1 is 7. Then we move the decimal over, so it equals 7. So we get 7x because of that first 2 terms. Then we multiply 2 times 7, which is equal to 14y. And then we multiply that 2 times the 9z, which would equal to 18z. And this would be our final solution to this problem.